I'm going to see if I can explain to you how SSH works in the context of GitHub. So one of the things that happens is you want to basically you go to a GitHub repo and you want to copy that onto your server. And then you want to be able to update those files and sync it with the GitHub repo. And it used to be that you could just go over to HTTPS and do a Git clone off of HTTPS. And, you could just basically do a git add and a git commit and a git push, and all of this would just work fine. Nowadays, they actually require you to do a whole SSH thing in order for you to complete that process. And it's kind of annoying because you can't just use your username and password anymore. You actually have to have SSH keys. And the thing about this is that it can be very confusing if you don't know anything about it. And I actually learned this all through a bit of trial and error, and I wanted to show you guys how to do this properly based on what I learned in a way that it kind of makes sense. Okay? So I'm going to use an analogy that kind of it helped. I thought of it as I was laying in bed, and I wanted to share it with you guys. So I'm going to create an analogy. Okay. This is, make him orange. This guy's name is Bob. Okay. Okay. Can I add text? Sorry, this is the first time I'm doing this. Bear with me. This is Bob. All right. And then we have another guy. We'll use this one. And we'll make him, I don't know, green. And then we have Frank. So we've got Bob and Frank, okay? Now, Bob and Frank were very good friends in middle school. They were super good friends. They had lots of good times together. And, they were just the best of friends, and they did lots of things together. And they were such good friends that they actually, in middle school, they invented their own language that nobody else knew. Only Bob and Frank knew this language, okay? So the rest of the world, they just spoke, they lived in America, so let's just say the rest of America spoke English, but Bob and Frank had a special language that only they knew. And nobody else understood them when they were talking, okay? So in middle school, they had this language that they would speak, and then as they grew older, things changed. They went to college, and actually Frank moves away, and he moves to a completely different city, okay? And while Frank is away, they kind of lose touch over time. They life happens, they get married, have kids, they kind of quit talking to each other, still good friends, but, they just sort of lose touch. And as this is going on, right, Bob gets older, he grows a mustache, he loses his hair, some different things happen. He doesn't look like he did when he was in middle school. He's a lot older now. He's in his 40s. He's not that young guy that Frank knew. And then Frank comes back to town, visiting family or something like that, and he runs into Bob. And Bob looks nothing like he used to, right? And Frank doesn't recognize him. So, he runs into Bob, and Bob says, "Frank, it's me, it's Bob." And Frank goes, "Wait, what are you talking about? You don't look anything like Bob. I knew Bob pretty well, and you don't look anything like him." And Bob goes, "No, really, it's me, I promise. I know. Ask me anything. I'll prove to you that I'm actually Bob." So Frank goes, "Okay, Bob, if you really are Bob, we used to speak this language when we were in middle school. And I'm going to give you a message written in our secret language. And if you can translate that message, it will prove to me that you're actually Bob. And so Frank, I know this is probably a little bit redundant, but let's see. Oh, Frank takes a message, he hands it to Bob, and Bob translates that message and hands it back to Frank and says, I translated the message. It'll say exactly what you expect it to say because I know the language. Frank opens up the envelope and he does see that, in fact, Bob translated it properly. So Frank now knows, without a shadow of a doubt, this is Bob, this is my old friend. And then they embrace each other and they hug, and all is well again. Okay? So let me just explain to you what this story means. Frank is you. Or I should say, Frank is GitHub. And Bob is you or your server. All right? Your server has special knowledge to be able to translate something that GitHub gives you. And the way that this works is, and it's not exactly like the analogy that I gave you, but let me see if this will help. All right. Let's see. Bear with me. All right. We'll get 2 keys. Let me just kind of elaborate on what I mean by all this, the essence of my story. All right. And the way it actually works is slightly different than the analogy I gave, but for the purpose of illustration, I think that this is a really good way to explain how SSH works. So, oopsie, private. Hold on 1 second. Private. I think I spelled that wrong. Let me just check the spelling, because there we go. Yeah, don't judge me, all right? Okay. All right. Let me zoom out here a little bit. All right. Bear with me. Sorry about this. I didn't plan this very well. Okay. So what happens is your computer, let's say this could be your laptop, it could be your server, whatever it is. Every computer that you work with has the ability to generate a key pair. Okay? They're called a public key and a private key. All right? And what do these keys do? So the private key can decrypt a message, and the public key can encrypt a message. All right? So if you have some text, a message, anything, and you can, let's say you have a laptop, and this is your laptop. You say, I want to generate a new SSH key pair. So your computer generates the private key and the public key. The private key has the ability to decrypt any message. So you have a message, that's like a long string of characters, and this key can decrypt it. It can make it make sense. The public key is a key that can encrypt a message. So you feed it any kind of a message and it basically scrambles it up and makes it look weird. And you can't read it. And you take this, let's see, you have a message, and I'm going to change the color of this message just because I'm weird like that. All right, so you type a message, it doesn't matter what it is, you feed it through the public key, and it comes out scrambled. It's not recognizable even as a message. And then if you feed that into the private key, it will be decrypted back into its original form. So encryption scrambles, and then decryption descrambles, okay? And they're separate. The decryption key, it cannot scramble a message. Only the encryption key can scramble a message. So this is a scrambler, and this is a descrambler, okay? So what happens is you can make as many copies of these keys as you want. And you can take this, we'll copy it, and then we will paste it, and then you give it to GitHub, right? Now, GitHub does not have a copy of the private key, but it does have a copy of the public key, the encryptor. So what happens is GitHub will encrypt this message. GitHub says, I'm going to make a message and I'm going to encrypt it and then send it over to you, right? Now, you are the guy who made these keys, so you have both of them, and you gave a copy of the public key to GitHub. So all you have to do is say, all right, I'm going to send it through my decryptor and then send it back to GitHub. And GitHub is going to say, hey, this matches the message that I sent him before I encrypted it. So he's good. I can allow him to modify my server. All right? So I hope that kind of makes sense. He's an old friend that you are like his old friend, that you are trying to prove that you can decrypt his message. So he has the ability to encrypt it and send it over to you, and you have the ability to decrypt it and send it back to him. And if it matches the message that he originally sent you, he's going to approve you to work to get these files. I just realized that this says GitHub. Wow, I cannot spell. All right, so let me give you an example of how this works. Let's create, I'm going to go over to my Google Cloud here. Let's see. Yeah, sorry. Now, this Google Cloud is a terminal that is a server in my cloud. So my server is like basically me. And then we also have, GitHub, which is basically like GitHub, right? Let me just establish. Okay, so let's create a new user. Let me see, add user. We're going to call this test user. Okay. All right, so let's see. So test user. All right, so I have this test user right here. Now, if I try to clone this private repo, right, with the SSH, I'm going to, let's see. Actually, I'm going to go to the root directory of this user. All right, there's nothing in this directory, but I'm going to do a git clone and paste in this repo, and it's going to do some stuff. Yes, I want to try and accept the fingerprint. Okay, and it's going to give me this error that says, please make sure you have the correct access rights and the repository exists. So basically, I said, hey, I want to clone this repo, and Git sent me a message, an encrypted message to me, but I don't have these keys. I don't have any of these keys. So I couldn't decrypt it, and when I sent it back, Git said, hey, this message is still scrambled. You didn't decrypt it. I'm not going to let you download Jack. So that's basically what happened. So let me generate some SSH keys. So let's do that by doing an SSH keygen, which is this command right here. Make sure and add your email to this. gmail.com. All right. So we generated some SSH keys. Usually I have to add a passphrase to these SSH keys. Okay, so I generated some SSH keys. So now my server has both of these SSH keys, right? So now I've got them. So let's see, I'm going to try it again. Now I have some SSH keys. I'm going to do a git clone. Let's see if we can git clone. And it says the exact same error. So what happened? So GitHub sent me a message, and I decrypted the message and sent it back, except GitHub does not have a copy of my public key. I didn't give him a copy of it, right? So it sent me a message, and I maybe even could decrypt it and send it back to him, but it wasn't encrypted, so it didn't go through that part of the process. So essentially, let's go find that public key. So let's go to cd my home directory /.ssh, which is where the keys are stored. ls. Okay, so I have 1, 2, 3 files. The known hosts you don't need to worry about because that has to do with something different. We have the private key, which, remember, the private key is used to decrypt messages, and we also have the public key right here, which is used to encrypt messages. So we just need to take this public key, copy it, and send it over to GitHub so that it has one, right? So let's do a cat. Let's cat out that public key. Well, there it is. So all you have to do is take this, copy it, and something else that you might want to know is you want to make sure that there's no trailing spaces at the beginning or the end, or which is why I prefer doing it this way. So we can go to edit and then let's see, Command C. Hopefully that works. Now let's go over to GitHub and do where is it? Settings, SSH and GPG keys. We're going to add a new SSH key, and in here we're going to say test server. Now this title is probably just going to be, I mean, you can name it whatever you want, but I generally title it the name of the computer that this private key came from, or I mean this public key came from. And then you come down here and you paste it down there and make sure that that's right. I don't know what I'm doing. And W7K, yep, that's it. So we're going to add that SSH key. Oops. I can use my password. Sorry, guys. We might need to log back in. Okay, so let's see. Here it is, test server. This is the key that we just added. So now, if you look back at our diagram, we did give GitHub a public key. So when GitHub is going to send us a message, it's going to go through this public key first. All right. So let's go back to our server. Let's cd back to our home directory. And now, when I try to do a git clone, going all the way back to the Git repo, we're going to copy this. So we're doing Git Clone. And we paste it. Guess what? We have to press the password for our SSH key because it asked us for a password. You don't have to do that step when you're creating the SSH keys, but I did. Press enter. And guess what? GitHub just sent us a message to our server. We used our private key to decrypt it. We sent it back. And now GitHub has approved us. Now, this whole thing about sending this message through this process, it happens in the background. Like, you don't see any of that happen. This is just GitHub approving us. We basically said we are who we say we are because we were able to decrypt the message that you encrypted through that public key. And that's the part that I didn't really understand until after like a long time of trying to figure this out. So I hope that helps you kind of understand what this whole nonsense is about GitHub and their public and private keys. Essentially, this replaces you entering your password, because if they have a copy of this public key, they don't need your password because you are able to verify that you are who you say you are because you can decrypt any message that they send you. So if GitHub needs to prove, or you need to prove to GitHub that you are able to download repos and update repos and stuff like that, all GitHub has to do is send you a message, and then through the encrypted key, and then you decrypt it. You've proven that you are who you say you are, and now you can do anything that you want. And that's how this whole thing about the SSH works. They just want to make sure that you have a key pair, and you're able to, and that the public key is on their server, and that you can decrypt a message from that public, from the message through the generated public key. Anyways, I hope that helps you guys. If it did, I hope it helped you. Let me know if you need any more help with it, and I will try and help you the best that I can. Thanks for listening. And sorry it took me so long. I'll talk to you later. Bye.